Alright guys, we are starting Chapter 2. Chapter 2, the first part is going to be working on solving equations. Hopefully you remember some of this from last year. The first two sections should be a review, and then starting in Section 3, we're going to be working with multi-step equations, which take a little bit more time. So we're going to just spend some time reviewing. First thing I have for you is a definition, and the definition equivalent equations. We've already had a previous definition that's similar to it, which was equivalent expressions. But equivalent equations are equations that have the same solution or solutions. Okay. When we're solving one-step equations, we have a few things that we need to remember just as a recall, so make sure you're writing these down. When we are solving equations, whatever you do to one side, you must do to the other. Remember, since we're dealing with an equation, we want to keep things equal. So if you add 1 to the left side, you have to add 1 to the right side. We're going to use inverse operations to solve equations. So our inverse operations, another definition, these are going to be operations that undo each other. So almost think opposite. Our first set is addition and subtraction. So if our equation says x plus 3, the opposite of adding 3 would then be to subtract 3. The next step is multiplication and division. So if it says 3 times x, to undo that we would then divide by 3. And then the last inverse operation set we have, we're not going to be working with for a while, but I do think it's worth writing down, a square and a square root. So if you have an x squared, the way to undo that would be take the square root of that. Alright, another thing really important, so I want to make sure we write it again, the sign in front of the term tells if it is negative or positive. We always have to be in the habit of looking in front, never behind. So let's look at some examples. Very basic one, 15 plus s equals 42. We want to solve for s. So the 15 in front of it, there is nothing. That means it's positive, so the opposite of a plus would be minus. So we need to subtract 15 from both sides. When we do so, our 15s cancel, and so we're left with s equals 42 minus 15 is 27. Now when we're solving equations, we can always check our answer, and I'm going to be in the habit of checking these just to make sure we're doing it correctly. That's the nice thing about math. You never have to wonder, there's always a way to check. So to check it, start by rewriting the original equation, 15 plus s equals 42. Now we want to plug in 27 in for s. We just solved that s equals 27, so plug that in. And then we need to do the math on the left-hand side. 15 plus 27 equals 42. 42 equals 42, so a little check mark means yes, great, they equal each other. We solved for the correct answer then. Next example, negative 12 plus x equals 17. Now a common mistake for this one is to find that plus sign and do the opposite, which is subtraction. However, if we look in front of that 12, we see that it's negative. Negative and the subtraction sign we're going to kind of use interchangeably, so the opposite of a negative 12 is a positive 12. That means we're going to add 12 to both sides. So when I do that, my 12s cancel. I'm left with x equals 29. I can go ahead and check it by rewriting the original equation, negative 12 plus x equals 17. Plug in 29 for x, so I have negative 12 plus 29 equals 17. And then when I solve on the left-hand side, negative 12 plus 29 equals 17, and 17 equals 17, so that earned a check mark. Alright, so that was an addition-subtraction example. Right now we have a multiplication example. It says 2 times x equals 3/5. So find the side that has the variable. That says 2 times x. So the opposite of multiplication is division. So I'm going to divide both sides by 2. Now I'm going to need to do a little bit of scratch work. It says 3/5 divided by 2, so I rewrote that using the division symbol instead of the fraction line. Reminder, when we divide with fractions, we need to do the keep, change, flip. Then we multiply, we get 3/10. So plugging that in, x equals 3/10. Checking that, rewriting my original equation, 2x equals 3/5. Plug in 3/10. So I have 2 times 3/10 equals 3/5. I can do some cross canceling. I get 3/5 equals 3/5. All right, x over 5 equals -12 is our next example. Looking at the left-hand side, that reminder that fraction line means division. So it says x divided by 5. So the opposite of division is multiplication. So since we are taking that variable and dividing it by 5, then we need to multiply by 5. Okay, one common mistake is to multiply by that -12 instead. So we want to multiply both sides by 5. When we do so, we get x equals -60. Plugging, oh, I didn't check that one, sorry guys. I think this is our last example that I have for us. 5/2 x equals 15. Just kind of a shortcut, saving you some time on how to solve when we have a fraction times a variable. However, so our steps would tell us, well, if it says a fraction times a variable, then we need to divide by that fraction. However, recall, when you're dividing by fractions, you're really going to multiply by the reciprocal. So we can just take that left-hand side, and instead of dividing by 5/2, we can multiply by its reciprocal, which is 2/5. Okay, so on that left-hand side, my 2's cancel, my 5's cancel. I'm left with x equals. Then on the right-hand side, if I do some cross-canceling, my 1 and my 15, they reduce. I'm left with 6/1, which equals 6. Checking my work quickly, so I have 5/2 times x equals 15. Plugging in 6. Doing some cross-canceling. I now have 15 equals 15. Great, I did that correctly. Reminders, you're going through these notes. Everything that's on this video needs to be on your notebook.